Welcome back, everybody. Today we will continue with our normal distribution and we are going to solve more examples on normal distribution. We already have the fundamental idea of normal distribution. Today the focus will be to solve the examples. So from your note catcher, we are going to start with example number 3. Make sure you have your calculator ready and also your note catcher ready so that you can start filling it. So let's begin with this example. First, we are going to read the problem and find out what is given. The average per capita spending on healthcare in the United States is 5,272. They say that this is the average spending. So that's your mean or average. If the standard deviation is $600, standard deviation or sigma is $600, and the distribution of the healthcare spending is approximately normal. So the spending is normal, which is shown here. So if we have X or spending along the X-axis, the distribution of the spending is normal with the mean of 5,274. So mean will be in the middle. So this is 5,274. What we are asked to do is we have to find the probability that a randomly selected person spends more than 5,800. So we want the probability that X is more than 5,800. What is that equal to? We need to find that. So 5,200 is here. So 5,800 will be somewhere there. So we'll show that. So that is 5,800. You need to label that. And we need to find the probability that X is more than 5,800. When I say more than, it is to the right. That means this probability is equal to the area over here. This is equal to this area. So we need to find that area that will be equal to the probability. So whenever we find the area, we use the normal CDF in our calculator. So we can write this probability. You can also write this down. Probability that X is greater than 5,800 is equal to, in order to find this area in calculator, to find that area in calculator, we use normal CDF. Normal CDF. Then we write the lower limit for the area. The lower limit is 5,800. 5,800. Then we write the upper limit. This goes all the way up to infinity. We write infinity as E99, positive infinity. Then we write the mean, which is 5,274. And then we write this standard deviation, which is 600. Now, we need to type this in our calculator and get the result. Now in TI-84 calculator, we go to second and then we go to vars and we go to number 2, which is normal cumulative distribution function number 2. Lower limit in our case is 5,800. So here we type 5,800. 5,800. The upper limit is infinity, E99. E is under this comma. So we press second and comma to get that E. Then 99, that is infinity. Mean in our question is 5,274. 5,274. And the standard deviation given was 600. So we type that 600. And we paste all this information in the main screen so that it looks like the way we have written on our paper. See, it is exactly the way we wrote on the paper. Then hit enter to get the result. So if you write that up to 4 decimal places, it should be 0.1903. 0.1903 when you round it to 4 decimal places. So the probability is 0.1903. Okay, next example. Let's find out what is given here and what we are asked to find. the average number of milligrams of sodium in certain brand of low salt microwave frozen dinner is 660 milligram. So they have given the average amount of sodium is 660 milligrams. So that is your average or mean. That is your mean. Make sure you annotate like that in the question so that it is easy for you. And the standard deviation is 35 milligram. So 35 milligram is the standard deviation. Assume that the variable is normally distributed. So this is the case of normal distribution. So if we draw the graph will look like this. Along the x-axis, you have the x value, okay? And this is your function f of x. That is given to you with the mean of 660 milligram. So in the middle here, you have the mean. So if I want to show it here, this is the mean, 660 milligram is the mean. And this height is the standard deviation. If you want to know how high is this is equal to standard deviation or 35. Now, we are asked to find the probability. This is our question. We have to find the probability that the sodium content will be less than 650 milligrams. So we want the probability that X is less than 650 milligram. What is that equal to? We need to find that. So if we look at the graph one more time, here is 660. So 650 will be somewhere here to the left of 660. So first we are going to label that 650. So that is my 650. And we need to find the probability that the sodium content will be less than 650. Less than is to the left. So that probability is equal to this area. So whenever you are solving any problem related to normal distribution, you need to draw the curve, you have to label it, and then you use your calculator. So we need to find this area. So we know that in order to find the area, we use the TI-84 calculator, and this is how we find probability that X is less than 650 is equal to, we use normal CDF, we use normal CDF. The lower limit is negative E99. The upper limit for this area is 650. Mean is 660. And the standard deviation is 35. So we need to type that in calculator to get the result. Now, in TI-84 calculator, we go to second and then vars. Number 2, which is normal cumulative distribution function. Number 2, we put the lower limit. In our case, lower limit is negative infinity. So negative, second and comma will give you E99 because negative E99 is negative infinity. Now the upper limit in our case is 650. 650. Mean is 660. And the standard deviation, it is 35. We paste all this information in the main screen so that it looks like our writing. Just like that. That's what we wrote on paper. Now hit enter to get the result. So we get the result if you write up to 4 decimal places. You can see that up to 4 decimal places, it is 0.3875. So that is the probability. Okay, so we got the probability here. We go to next example now. Let's find out what is asked in this question. The average height of certain age group of people is 53 inches. That is the average height given to you. That's your mean. The standard deviation is 4 inches. So 4 inches is the standard deviation. If the variable is normally distributed, so the distribution of the height is normal. So this is normal distribution with the random variable along the x-axis and the probability distribution function f of x, where mean in the middle Okay, mean in the middle is 53. And the standard deviation or this height is 4 inches. Now the question is, we have to find the probability. You can see the question is, find the probability that a selected individual's height will be between 51 and 57 inches. So here in this example, we want the probability, okay, we want the probability that X is between 51 and 57. X is between 51 and 57. What is this equal to? We need to find that. So 53 is here. 51 will be somewhere here. So let's label that. So that is 51. And then 57 should be somewhere there, a little bit far. So 57 should be somewhere there. So we want to find the probability that the randomly selected X value or the height is between 51 and 57, which is equal to the area between those two. So it is equal to this area. So make sure you label that area, say it like this. Okay. So we need to find the probability, which is same as the area under the curve between 51 and 57. So we can use our TI-84 calculator again. So what we know is probability that X is between 51 and 57 is equal to, we use normal CDF in our calculator. The lower limit is 51. Upper limit is 57. Mean is 53. And standard deviation is 4. So we need to type this in TI-84 calculator to get the value of the probability. Now in calculator, we press second and then vars, and we go to number 2 for normal cumulative distribution function. Number 2, lower limit in our case is 51. Upper limit is 57. The mean is 53. And the standard deviation is 4. Now paste this information in the main screen so that it will look similar to what we have written down. That one. Now hit enter. And we got the result. And if you write up to 4 decimal places, it should be 0.5328. So the probability is 0.5328. So this is the end of this example. So up to here, if you look at these 3 examples, we work on, you can check here, the first one we did here. We calculate the probability or area to the right of a given value. In the second example, we calculate the probability or area to the left of this value, 650. And in the third example, we calculate the area between these two values. Now in next examples, what we are going to do is, in the upcoming examples, we are going to calculate the values like this one, values like 650 or 5800, when this area is given. When the area is given or probability is given, how we can find the random variable. And there we'll be using something called the inverse normal distribution. So here is that example. Let's begin with this. Make sure you have your calculator ready. Assume that the reading at freezing on a batch of thermometers are normally distributed. So we are looking at the reading on certain batch of thermometer, and we saw that the reading is normally distributed with the mean of 0, that's your mean, and standard deviation 1. Mean 0 and standard deviation 1, that means this is a standard normal distribution. So you have your X or temperature along the x-axis. This is our normal distribution, f of x. Mean is here in the middle, the reading on the thermometer, which is 0 degrees Celsius. And standard deviation is 1, or this height is 1. Now, a single thermometer is randomly selected and tested. So out of all thermometers in the batch, one thermometer is selected and it's tested. We have to find the P39, or the meaning of that is the 39th percentile. So what value along this x-axis is 39th percentile? You have every single value from here. In the middle, you know that in a normal distribution here in the middle, you have mean, median, and mode. Median is the 50th percentile, is there. What is the 39th percentile? So if 50 is here, 39 should be somewhere here. So maybe this one is P39. So what is this equal to? If this is 39th percentile, meaning of that is if we go from here all the way up to here, when it is 100, you have 100% area. When you go from here up to this 0 or median, you have 50% area. That means when you go up to 39th percentile, this area here is 39% area. So the area that you want to label here, this is 39%, or 0.39. 39% is same as 0.39. So this is the area. Now we need to find this x value. What is that x value for which the area is 0.39? So what we do is here, x equal to, when we find this x value, or in this case, it is also equivalent to the z-score because this is the standard normal distribution. This is equal to, we have to use this command in the TI-84 calculator. Inverse, please write this down. Inverse normal, that is the command that we use in our calculator. Inverse normal. Then first we write the area. This area, when we write the area here, this must be the area to the left of this x value. If this is my x value that I'm looking for, to the left of that, the area is 0.39. 0.39 is area to the left of that. Then comma. Then you have to put the mean, which is 0. Then you have to put the standard deviation, that's 1. Okay, in our calculator. So the general command is, if you want to write the general formula, x is equal to, I'm writing that here, inverse normal. First we write the area. So it is area to the left of x. Area to the left of x. Always it must be the area to the left of x. If I'm calculating this x, it should be the area to the left of x, comma. You should have the mean after that, and then the standard deviation. This is the standard comment that we use in our TI-84 calculator to find the value of x. Okay. In our TI-84 calculator, we go to second, then vars. In this case, we are using inverse normal, which is number 3. You can see here, inverse normal is in number 3. So press number 3 and type your area. Your area is 0.39. 0.39 is the area. In this case, mean is 0, standard deviation is 1, no doubt on that. And then paste this on the main screen. This is exactly what we wrote down on paper. Okay. Then hit enter to see the result. Now you can hit enter to see the result. So when you hit enter, you got the negative value, and that makes sense because you have 0 in the middle. So let's first write this on the paper. This is equal to negative, you can write that down, negative 0.2793. The value of x is negative 0.2793 because this is 0 and the values on the left are negative, and that makes sense. So always remember, when you're calculating the x value, what you have to do is you have to use the inverse normal function. You type the area to the left of X, then you type the mean, and then the standard deviation. Once you put that information in the calculator, you'll get the X value for which the area on the left is the given value. Here, it is 0.39. Let's take one more example so that it will be more clear. Here is that example. Example 7 in your note catcher. Of fruits weight are normally distributed with a mean of 295 gram. That is your mean. Mean of 295 gram. And standard deviation 34 gram. That's your sigma. Okay, they are normally distributed. So the distribution is normal. You have X, that is the weight of the fruit along the x-axis, with the mean in the middle, that is 295. Mean is 295. Now, the question is the heaviest 17%. When we say heaviest, this is the weight. The lighter weights are here. The heaviest weight, they increase and they go to this side. So the heaviest 17%, the top 17%, the top 17% will be here. If it is the lighter 17%, they will be on this side. So heaviest 17% of the fruit weigh more than how many grams? So if you want to label this heaviest 17%, your heaviest 17% will be here. This is the heaviest 17%. Or this area is 0.17. The question is, the heaviest 17% of the fruit which are here weigh more than how many grams? So what is this weight here? This one is how much? We need to find. What is that X equal to? Weigh more than 17 grams. So what is that weight? We need to find that. Okay. Now, we are going to use TI-84 calculator to calculate this X value. So let's use that. Here, X is equal to, we use inverse normal. Then we type the area. First, we type the area, but the area must be, okay, the area must be the area on the left. The area must be area on the left. Everybody look at it very carefully. Area on the right of X is 0.17. So what is the area on the left? The total area is 1. Okay, so it will be 1 minus 0.17. What is that equal to? Tell me. Area on the left is?
The right or the left?
Say that again.
The area on the right or on the left?
The area on the right is 0.17, but in our calculator, we have to use, in our calculator, look here, we have to use the area on the left. All the time, we have to use the area on the left. Area on the right is 0.17. So what is the area on the left?
0.83.
0.83, because it is 1 minus 0.17. So it is 0.83. 0.83. Okay, that's what you have to do. And then we need to type the mean, which is 295. Then we have to type the standard deviation, which is 34. Okay, now we are going to type all this information in our calculator. Okay, there is my TI-84 calculator. Now let's go to second, then vars and number 3. First we type the area on the left. Area on the left is 0.83. Then the mean is 295. After that, we have the standard deviation, which is 34. Paste that information in the main screen. That's what we wrote on paper. Enter it and you got the result. And our result is, just write that down, 327.4416 gram. So we got X equal to 327 because 395 is here. Okay. 295 is here. So 327 can be here, which makes sense. But if you look at the question, we are asked to give the answer to the nearest gram. So this is 327.4416. So if you round it to the nearest whole number, what will be the result? It will be approximately 327 grams. Okay, if you round it to the nearest whole number, it is 327 grams.